Today we're going to be learning, or tonight for that matter, you should be watching this right now in the evening on Wednesday, but this lesson is going backwards from what we did today. It is going from mass now to moles. On Wednesday's lessons we went from moles to mass. So it's kind of what the equation is, but now just flip it. In the problem, it's going to have the measurement in grams. So that's going to be given. Again, anything that's given was always going to be on the left-hand side, and it's going to be above the line. You're going to multiply this times a ratio, and this ratio now, that's in the middle, has to do with grams. This is where you use your periodic table, and this is also where you measure your molar mass. You have to add all of your elements together, and if it has H3, then you have to add 3 hydrogens together, so that means it would be 3.03, not just 1.01. This is a ratio, so again, you're using 1 mole will be on top no matter what, and underneath the line is going to be your molar mass from the periodic table. The next ratio that you multiply is going to be the molar mass ratio, or excuse me, the mole ratio. This is the mole of the unknown. This is what you want to end up with, so it has to be on top. Then underneath is going to be mole of the known, in order for these to cross-cancel out. This here, this ratio, is going to be a mole ratio using your balance equation again. You're not using your periodic table, you're using the balanced equation, and this is where you use your coefficients. In the end, you're going to get an amount of a substance in moles, it's measured in moles, and then you are completely done. So now we're going to do an example. This first problem that's in the textbook, which is on page 309, the first step of nitric acid, the catalytic oxidation of ammonia, is as follows. We have NH3 plus O2 yields NO plus H2O. However, this is unbalanced. So I'm going to go ahead and I'm going to balance them for you. Now that this equation is balanced, we can move forward with step 1. We want to know if we have the reaction using 824 grams of ammonia, how many moles of nitric oxide are produced. The second one is how much water is produced, again in moles. So I'm going to go ahead and start off with the NO first, over here to your right. First thing is what is known, and that is the grams. We're going to go ahead and put 824 grams of ammonia. According to the equation, we want to get rid of the grams. So again, we need to use a periodic table. And we want to end up in moles. The mass for NH3 is 17.04 grams. Again, this is taking from the periodic table. I'm using 1 nitrogen, which is 14.01, and hydrogen, which is 1.01, but times 3, and altogether we get 17.04. The last conversion then is going to be with the moles, and that's the mole-to-mole ratio. We have the mole ratio of NH3, which we want to get rid of for cross-cancellation. And then what we want to end up with is the NO. So NO has to go on top. I hope you guys can see this. With one, now we look at the ratio to where we have, let's see, we have 4 moles of NH3, so 4 is going to go on the bottom. And the moles of NO, we also have 4, so those are also going to go on top. My units will cancel, and then what we're left off with was 824 grams times 1 divided by 17.04 times 4 over 4, or is 1, and your answer comes up to 48.4. of NO. I hope you guys got the side part. If not, I'll go over it in class. Part B is we're going to do the same setup, but now we want to see how much moles of water are produced. Again, same setup. What is the known? Our known here is the 824. 824 grams of NH3. We want to get rid of that NH3 because we want to figure out how many moles we have. So 1 mole of NH3 is, again, 17.04 grams. Same periodic table information. So in the end, these will cancel and those 2 units will cancel out. Then we look at the Moldable Ratio. We want this to cancel out, so we want to have the NH3 down here. And what do we want to end up with? Right here, water. So that should be on the top all the way to the far right. We don't know yet. We haven't plugged in the numbers yet, so let's look at our balance equation. Remember, at this step, you look at your coefficients and your balance equation. We had mole of NH3, which again is right here, so that is 4. Now we find water, and if you notice here, water, my coefficient is 6. When I cross cancel and I do the math, my numbers come up to 72.5 moles of water. So this is how you do the steps going from mass to moles. Come with some questions so that we can start early, right away with some examples, and then we can work from mass to moles to moles to mass again. So we're going from mass to mass. Have a great night. Study hard.